Hello again, students. And now we're going to solve systems by elimination where we use multiplication to raise a variable. All right, let's take a look at the lesson here. Now, the question today is, what do you do when the variable is not the same or opposite in value of its like term? Okay. Now, if you remember in the last lesson, it was fairly easy. It was like you had x and then negative x. Or you had like A and then positive A again or something like that, or I think it was S and S. So then you just subtracted the second equation from the first one so that the S's were eliminated, okay? But in this case, uh, they're not set up quite as easily. So one of the interesting things is when you have an equation, it's very similar to a fraction. Now you may remember with fractions how you can reduce a fraction, like 3/6 can be reduced to 1/2, okay? But in the same sense, you can also raise a fraction. So 1/2 can be raised or multiplied to 3/6, or to 4/8, or 5/10, or 6/12, okay? Simply by multiplying the numerator and the denominator by the same number. Equations work the same way. Take a look at this little mini equation here. 2x equals 10. So what would x equal? Yes, that is correct. It would equal 5. Okay. If you divide both sides by 2, then you get x equals 5. But what happens if I were to raise 2x equals 10? And let me just do this. 2x equals 10. I'm going to multiply the entire equation by 40. Okay. 2 times 40 would be 80x. 10 times 40 would be 400. So now I have 80x equals 400. So I divide both sides by 80 and I get x equals 5. You notice I got the exact same solution, okay? One of the nice things about equations is that they are proportionate, the left and the right side of the equation, to each other, meaning that they kind of have a fixed relationship, the left and the right side. So if x equals 5 in the simple equation, and I complicate the equation by multiplying both sides, the answer is still going to be the same. 80 is still 1/5 of 400, and 2 is still 1/5 of 10, okay? So in the same sense, the value of x is going to remain the same. It's going to remain 5. Now, why do I say that? Because in today's lesson, we're going to have to take two equations, and we're going to have to multiply in order to get the answer. Now, let's take a look at the steps. Step 1 is different than the last lesson, but all the other steps are the same. Step 1 was raise one or more equations by multiplication to get like terms that match the absolute value of the like term. Now that sounds way more complicated than it is, but then the rest of the steps are the same. Write vertically, organize into like terms, add or subtract to eliminate a variable, solve for one variable, substitute into either equation, and write the solution as an ordered pair. Now, I'm going to take this equation and I'm going to write it under the other equation. 7x minus 5y is equal to 17. Now I'm looking at my two equations here, and if I were to add this, I would get 5x plus 10y is equal to, I don't know, whatever 32 minus 17 is. Don't want to figure that out in my head right this second. Now, the problem is, when I do this, I'm not going to eliminate one of my variables. So let me take a look at my variables. I have my x variables are 7x's and 2x's. Now 7 and 2 don't really have any common factors. Okay, this 2 doesn't go into 7. So I don't think I'm going to do the x ones. Let's take a look at the y terms, 15 and 5. Wait, they do have some common factors. 5 goes into both numbers, okay? And 3 goes into 15. So what I'm going to do is I'm going to multiply my entire equation times 3. Now, why am I picking 3? You have to have your eyes on the prize here. I want you to look at the goal of what is this going to be. So if I multiply the entire equation by 3, then 3 times 7x would be 21x. 3 times negative 5y would be negative 15y. And 3 times 17, 7, 14, 21, would be 51. Okay. Now, I'm going to go ahead and rewrite my first equation again over my second equation. Okay. Now, you'll notice something when I look at my like terms, 15y and negative 15y are opposites. So now I can eliminate per the last lesson, part 1. Okay. So let's go ahead and do the steps. Negative 2x plus 21x. One's positive, one's negative. So yes, Aaliyah, I subtract. Okay. So that would be 19x. Positive 15y, negative 15y would be 0. Bring down the equal sign. 31 plus 51. Oh, that's a negative 31. So then I end up with 20. Let me just make sure. 50 minus 30 is 20. 1 minus 1 is 0. So yeah, 20 plus 0 is 20. Okay. So now I have 19x equals 20. So if I divide both sides by 19, then x is going to equal, it's a fraction that's improper, but I'm just going to leave it. X is equal to 20 over 19, which would be 1 and 1/19 if I really wanted to change it. So the point here is, in this case, I had to multiply in this step times 3 in order to get a like term that was the absolute value of the other like term. Now I say the absolute value because if this was positive, then I would have positive 15 down here. Since it was negative, I have negative 15 down here. Since I have negative 15, then I chose to add them in order to eliminate. If that was positive 15, I would choose to subtract the terms to eliminate. Okay? So that's why I wrote absolute value, because it can be either negative or positive. It has to be, it's going to be one or the other, but the point is so that you can decide whether you add or subtract at the end. Now, when I multiplied the entire equation, just like I multiplied this entire equation, still got 5 both times, the equation is still equal and proportionate to the original equation. So it's still basically the same equation. It's just using larger numbers to represent it. Okay, let's go ahead to, that was problem 3 in the book, and by the way, this is on page 399. Let's go ahead and do the same thing with problem 4. Now I have 3x plus 2y equals 1, and 4x plus 3y equals negative 2. So I'm going to go ahead and write the second equation under the first equation here. Now, when I look at my like terms, I notice something. 3 and 2 have no common factors. 4 and 3 have no common factors. So I have to multiply both equations in order to get the answer that I'm looking for. Now, I can eliminate x if I can get 4 and 3 to raise to the same number, or I can eliminate y if I can get 3 and 2 to eliminate to the same number, or to turn to the same number. So I'm going to I'm going to go with the x term this time. So 4 times what makes 12? Because 3 and 4 both go into 12. Yes, that would be 3, and 3 times 4. Now, you'll see the number that I'm picking to multiply is just what number I can get to eliminate one of my variables. In this case, I want to change 3 and 4 into 12 because 3 and 4 both go into 12. So even though I multiply everything, everything's going to now change. But in this case, I'm just multiplying to change to what I need one variable to be. Everything else changing is just going to be happenstance. So 4 times 3x is 12x. 4 times 2y would be 8y. And 4 times 1 is 4. Okay? All right, 3 times 4x is 12x. 3 times 3y is 6y. 3 times negative 2 is negative 6. Okay, now you might ask the question, well, Mr. Bauer, 2y and 3y looks easy. I could change those both to 6. Yeah, you can. Whatever variable you choose to eliminate is fine. I just chose to eliminate x this time because all of the other ones I think I'd done, we eliminated y first, okay? So let me show you what to do with this one. Okay, so I have these two equations. 12x and 12x are both the same in the sense, not just that they have the same absolute value, but they are the exact same numbers. So I'm going to subtract because I'm going to eliminate the x. So 12x minus 12x is 0. 8y minus 6y is 2y. 4 minus negative 6, oh, remember, I'm subtracting a negative, so that means I have to actually add, would be 10. So I have 2y equals 10. Divide, I'm going to 0 plus. So the 0 doesn't count for anything, so I can just pretend it's not there. Then y equals 5. Okay? Now, to save time and not make this lesson excruciatingly long, I want to remind you of the other steps. Once you solve for one variable, you have to substitute it in either equation. So for example, in this one, I have x is equal to 20 over 19. I have to substitute that in as the value of x somewhere, and then go ahead and then solve so I can get an x and a y, so I can get an ordered pair. Same here, I have to substitute y, the value of y, 5, back into either the blue equation or the red equation here. Or, forgive me, I can go back to the original equations. I don't have to go to the ones that were raised by multiplication to get my value for x, okay? Because your answer is going to be an ordered pair. Now, in this case, I didn't find out what y is and I didn't find out what x is. But since these steps are the same as the last lesson, I think you can review them and go over them. All right, hope you enjoyed. Thank you much.